meeting is being recorded.
Hey, excellent. Good morning, everybody. Welcome back. Excited. There was lots of talk about the breaking into the web page over the weekend. So Ainsley over there was able to beat me getting into the hard level. I never made it into the hard level, so good job. And again, last week we went super fast just to get to the point where we could talk about what was going on with that Capture the Flag challenge, because it is now officially over. It ended on Monday, and I didn't know if they were going to be leaving everything up or not afterwards, and so I wanted you all to get a chance to play around with that. Whether that fully made sense to you or did not make sense to you is it's okay. Today we're going to be revisiting a little bit more of the LLMs and software engineering stuff. I'm going to scroll down here to a big giant note that I've added about what we'll be going over today. A little bit farther, this note right here with all the things that we will be covering in class today. And let's make this a little bit bigger. There we go. And it looks like the projector is not blurry, so that's nice. Today in class, our overall big picture goal, we're going to pick up where we left off from last Monday. And I've got 5 things here that I want us to talk about. The first is this idea of continuous integration and using large language models with continuous integration. If you haven't seen this term before, it's a way of like automatically running your test cases as you're doing things. And we've talked a lot. You guys asked really great questions last time about like API keys and those leaking. We'll see how to be able to use GitHub Actions with LLMs with their API keys today. We'll also talk about, in general, good practices for writing programs with large language models, writing good test cases with large language models so that you can have some good assurance that your code is doing what you want it to do. One of the big overarching problems with students, whenever I'm working with students on a project, whether it's for, say, like the data science capstone or a thesis or a class, or you're working with some company on an internship and you're asking me about advice for things, students 90% of the time have really bad test cases about what they're working on, which makes it really hard for me to come up to speed with your project, which makes it hard for me to give you good advice. And one of the things that really separates like junior programmers, novices, people who don't know what they're doing, from people who sort of know what they're doing, good programmers, is this ability to write good test cases. So we'll talk again about that today, a lot of emphasis on that today. When we're doing that, I'll also walk through some examples of how I use large language models to effectively write my own code. So we're not going to write too much code manually today. I'll do some live coding with the Grok LLM to help me out here. Again, this is one of the sort of things that I've seen students being very interested in, wanting to use large language models to help you write code. I've seen a lot of you try to do that and not do it very effectively. So I'll walk through how I do that, again, focusing on these test cases. And really, I guess the sort of meat of the things that we're going to be talking about today, sort of the way all these other things are going to come up, is that we've previously written this document summarizer. We've seen some examples of it working, but we're going to see today some examples of it not working because the documents are too large. And we'll see a technique that it doesn't really have a name, but I call it recursive summarization in order to handle these really large documents. A more popular term that you might have heard of before is retrieval augmented generation, or RAG. We'll probably talk about that as our next topic next week. And this will be the main overarching theme for today: handling documents that are too large. And then we'll probably also run into rate limits and see how to deal with that. So that's our rough agenda for today. A little bit of reminder of where we've done things, or where we left off before. A couple of other administrative things too. For your homework is going to be, I'll start with this last thing right here. Your homework is due this Sunday at midnight. And again, we're going to basically complete most of the stuff in class here. But if for whatever reason you can't complete it by this Sunday at midnight, my goal is that this class is not going to be like a super stressful class for you all, that you can all focus on just learning things, having fun in this class. So no points off if you don't get it submitted to Sakai Sunday at midnight. But if for whatever reason you can't do that, then you are behind in this class, and we should chat about where you're at and how to catch up. These things that we're talking about today, general principles of like what I think of as being like required for a minimal viable Git repository, like having these test cases and being able to use API keys with LLMs and so on. And in the future, and our homework assignments, I'm going to say a lot of things in the requirements, like I'll use this word reasonable a lot. Here I said the test cases are up to you, but they should be reasonable. And my standard of reasonable might be different than your standard of reasonable, but I'm not going to go into more details like explicitly about what I mean by reasonable in the instructions, because I want you to get familiar with some sort of like ambiguity in your instructions. And we'll be covering today how you make these sorts of reasonable test cases. But this is the sort of thing that's going to come up in all of your future assignments as well, creating these reasonable test cases for your assignments. Very last administrative thing is a couple of you have already submitted something to Sakai. That's okay if you've done that, but you'll probably need to update your repo in light of all the things that we talk about today for credit for the assignment. It's a lot of things. Any questions about anything at all before we get started? Ainsley.
So the new stuff for DocSum is just the GitHub Actions?
All of this is going to be related to the DocSum. So we're going to start off adding the GitHub Actions with the continuous integration, and then we'll add some actual like good test cases that handle these things down here. And those are all things that I'm expecting for your final submission. Good question. Okay. Was everybody able to get the DocSum stuff up and running on your own machines at this point? Able to connect to Grok and summarize things? I see a lot of head nods. Okay, that's all good. Okay, then let's dive right in here. There's a lot of things here, so I'm going to be tempted to go really fast throughout class today. I'm going to do a lot of, again, live coding of things and walking through verbally all the stuff that I'm doing. If at any point you have questions about anything, my eyes might be on the computer screen down here. Feel free just to shout something out, or you can raise your hand and I will get to you when I see you. But lots of questions is a good thing. Last time in class, you guys were asking lots of great questions about like the API keys and stuff. So I'm very encouraged about like you all asking questions. Please continue to do that. Okay, so quick summary of some Git stuff is up here. I have this link to the DocSum repository on GitHub. This is a link inside of my main class repository. This here is called a Git submodule. And if we were to click on this, this will take us to the DocSum repository where we left off. And you'll notice that there is nothing down here below these files, and there's only one folder up here. So this is exactly where we left off in class. And one of the things that's nice about Git is it allows you to sort of checkpoint exactly certain locations in a repository, certain timestamps in the repository, so that you can always go back in time. So this is the exact point in time where we left off in class. Since last class, though, I have added 2 new files to this repository, and we will go over what those 2 files are next. Those 2 files are related to this idea of continuous integration and getting these test cases up and running. If you were to just click on this repository, go to this repository, sort of like call it the naked version of this repository, the top level version of this repository, you notice that the URL up here just changed from this big, long, scary URL up here. And then when I click on the repository right here, it gets shorter, so that it's just mikeisbicky/docsum. Now there's 2 more files that have been added, this readme.md and this .github/workflows file right here. And this is sort of a minimal possible README file that you should be I want to say striving to get for all of your projects, but striving is too strong of a word because this should be like trivial to do. All I have here is a 1-sentence explanation about what my project does, and then one short example of using the project. This is how we ran it on our first day of class here, running docsum.py, and then this doc/declaration, and we get this long summary down here. The other thing that you should always have on all of your repositories is this little badge up here, which shows that you are currently passing your test cases. And anytime that I am, say, like seeing somebody else's repository, whether I'm like working on my own and just found this repository and think it might have good stuff for me, or if it's a student coming to me asking for feedback on their repository, these are like the minimum set of things that I expect it to have. And if the repository doesn't have these things, I just immediately move on and don't use it. So I always expect repositories to have some sort of test cases demonstrating that the repository does what the authors think it's doing, and some sort of example usage of that repository. Okay, this green test case badge up here, where does it come from? Well, in this new folder right here, this .github/workflows folder, I'll click on that for a second, and there's this file tests.yaml right here. The .yml extension is pronounced YAML. And this test.yaml file describes what tests are going to be run on my repository. I would not try to copy this like just looking at the screen and type it all out. Instead, in order for you to get a version of this file, I would go to on the internet to this location, and so you can have it on your computer and then copy and paste this into your own repository. And again, the location that this is supposed to be at is this .github/workflows. And then the name of this file doesn't actually matter as long as it ends in YAML, but it's customary to call it tests.yaml. I'm going to do a real quick overview of this file, what's going on here, and then we'll talk about where the API key information comes in. So this first line up here, this name:tests, it's just a standard thing up here. This on right here, this tells GitHub when it's going to run the test cases. So right now I have it configured, it'll run test cases every time I push something to the repository, or every time somebody issues a pull request, it'll run the test cases and check to see whether the pull request continues to pass the test cases. And then the more important part down here is under jobs. There's a lot of stuff going on here. Here under this Python section, there are 2 versions of Python that these test cases will be run with, 3.8 and 3.9. This environment right here, this is going to be a very important part, this Grok API key. We saw before that in order to run your code, you need to have the Grok API key environment variable set. And this is going to actually set that environment variable for all your future code. So this line 16 right here, super important to have. We'll talk about what's going on here in detail later, but the key idea here is that it's just setting that environment variable. Last time, or the first class, a handful of people asked about like, why do we use environment variables, or why am I using environment variables instead of things like the .env Python package? And this is one of the reasons right here, is because if you're running your code in some other environment that is not your own local computer, it is standard to pass around those API keys as environment variables, and that is what GitHub Actions is set up to do. So here's my environment variable. And then down here under steps, these are all the commands that will actually be run as part of my test cases. And so these are the commands that have to actually pass in order for the code to work. And so line 25 right here, installing everything, or installing Python pip. Line 26, installing our requirements.txt file. So this is one of the reasons why we had to include that requirements.txt file, is so that our test cases, GitHub Actions here would know to be able to install it, what packages it needs to install. And then the most important line here, line 29 right here, just actually running this file and making sure there's no errors. At this point, line 29 here is the only real like test case thing that we have, and it's not a great test case. All it does is run our program and check to see that there's no errors. It doesn't do anything beyond that. It doesn't check to make sure the output is correct in some way. It just makes sure there's no errors. So if you had, say, a syntax error, this command right here would fail, and then the badge on the README file would turn red up here if for some reason that line failed, this would turn red, and we would know that there's a problem with our code. I went through that pretty fast. Any questions so far? Yes, Max.
What would be a reasonable test, like other test cases?
Yeah, great question. The question is, what would be reasonable other test cases? And we'll get to that in like 5 minutes, reasonable other test cases. Before we can get to the reasonable other test cases, though, we need to talk about one last thing in order for this test to pass. That if you were to just immediately right now copy this file that we're looking at into your own GitHub repository, you would get that your test cases fail because your repository is not currently linked to your API keys in order to actually connect to the Grok server and run them. And so clicking back up here, test.yaml again, this line 16 right here is not going to work for you because you don't currently have a secret setup, which is your Grok API key. So your environment variable right here will be empty. And so when you run this line 29, it's going to fail. How do you fix that? On the settings tab up here, I'll click this settings tab in a new window. You can add new secrets to your GitHub repository. This code, let's see, secrets and variable right here, and then under actions right here, and then repository secrets right here. You click new repository secret, and the name of it doesn't matter. It's traditional to name it exactly the same thing as your environment variable though. Grok API key right here. And this is something that will not be available to anybody besides you. This is not included anywhere actually in the Git repository. It's not in the source code. There's no way that somebody else can have access to this. And the only way that it's connected to your repository is on this line 16 right here. This inside of the $ curly curly brace, this is like a do a substitution right here that will substitute that secret right here, setting this environment variable to what it's supposed to be for your API connection. And if you do that, then your docsum.py down here will actually be able to run, and you'll pass that test case. Yes?
So if it calls this test, like whenever anybody else does a poll, and when it runs the test, it runs it on your API key, is that a vulnerability?
It's a fantastic question, and this is exactly the right sort of question that you should be thinking to yourself about, like, how can I steal somebody else's API keys? And not necessarily because you want to steal other people's API keys, but because other people are thinking about that, about stealing your API key. And if we come back up to this actions secrets here, there's this line right here which addresses the question. So the question was, what if somebody else who's not related to this repository issues a pull request? Can they somehow use your API key? And the answer is no. That here, so it says, only people who've already been granted this collaborator access level will be able to use these secrets. And the secrets in particular are not passed to workflows that are triggered from a pull request. Or if somebody forks your repository, those secrets don't go with it. So at this point, if now that I've added this secret, if somebody else issues a pull request, I'll get a message first saying, like, do you want to actually run this, the test cases with your secrets on their potentially unsafe code.
If you have a public repo, is that gonna like trigger whenever anybody does a poll, or?
So if you have like a popular repository, something like, say like Python, the Python's hosted on GitHub here. All the collaborators who work on Python all use GitHub to actually create the Python program. There are thousands of contributors to Python, plus tens of thousands of non-contributors who still can and have created pull requests. And there's a very complicated system that they have of, there's only a very small number of people who actually are authorized to view those secrets. They have like a little council of about 10 people who can view those secrets in the Python repository. And yeah, very strict controls on that. So it would be possible to try to sneak in some code that could steal those secrets, but it would be a hard thing to do for a major repository like that. For your own personal repositories, it would be probably rare that somebody's trying to steal your secrets, and but I would do like a once over of what their pull request is, seeing what code they actually changed before approving it. Good questions. Fantastic questions. Any other questions so far? Okay. I did all that really fast, and so probably a lot of people, most of you not able to fully along with all the different steps that I had there. This would be something that you would should do after class on your own time to make sure that this is all working before you submit the homework. But then we're talking about, okay, what are some like better actual test cases to do besides just running on one small file? And that's what we will work on for the rest of class. The rest of class should all be things that easier to follow along with. And again, my like target of speed level, what I think I'm going at is that about half people would be able to follow along with typing the sort of at the rate that I'm going on in class. But feel free to like ask me to pause or re-explain something as I'm doing that. So the first thing that I want to do for more test cases is to add more documents here that I want to run the test cases on. And I already have a set of documents that I have created in our class repository that we can use. So I'll just use the back button here to go to our class repository here. And in this docs folder right here, I have a set of documents right here, just 6 documents that I would like you to be able to pass your test cases on. We've already talked about this declaration. That's the one that we've started with. And we'll go on to some of these other ones here next. The first thing that I need to do is to be able to get access to these documents. Lots of ways to do that. But I will do that by cloning this repository. And so I don't currently have a terminal windows open, so I'll open those real quick, go into my docsum location. Let's make these terminals bigger, cd proj/docsum ls. So I have this docs right here. Let's our docs.more. That's something I was playing around with earlier. We don't need that. And I'm going to clone git clone https://github.com/cmc-csci181-languages, the class repository right here. Clone that ls, so it just got added right here. Inside of this folder, there is the docs folder. So inside of the class repository folder, then the topic 0 folder right here, then the docs folder. And I want to move all of these documents into the docs folder for the docsum project down here. So press the up arrow, get back to the previous command, press the home button on my keyboard to get to the start of this command line, delete that, mv, and on my keyboard, take me to the end of the line over here, and a doc/star to move all of those documents into the docs folder right here. Hit enter, ls docs to see now, okay, I do in fact have all of these documents right here. This declaration right here is a little bit of a duplicate. These are the same exact files, just different file names. So I'll go ahead and delete that, rm for remove, docs/declaration, press tab for tab completion, so I don't have to type that out. And now I have all of those documents in this folder right here, be able to access them easily from my docsum project. And so I don't need the class repo anymore. I'll do rm-rf of that. The details of what I did right there aren't important about how I did it. Just the important thing is now in this docs folder, I have a bunch of other documents that I'll be able to run my code on. And let's see, I want to start with this news-mx.txt. We'll be starting with this one, and then the next one will be the constitution-mx.txt. Those will be the 2 I think that we'll use today. So if you're just downloading things one at a time, those will be the 2 to focus on. News-mx, what I'll start with, and constitution-mx, what we'll what we'll end with. And this news-mx, the first day of class in the morning, I just went to a elpais.com, a newspaper in Mexico, and the top article that was on their webpage, download it and put it right here. I'll use Vim to open that real quick just so we can see what it is, news-mx.txt. And you can see that it has a bunch of text in it, sort of looks like a news article. Maybe you don't speak Spanish though, so you don't understand what's going on inside of here. But it does look like it's got some text inside of it, and it does look like it is in Spanish over here. But it doesn't matter if you speak Spanish or not, because we can still use our large language model to summarize this for us. And if I do a Python 3 docs.py and then docs/news-mx.txt, I get my module not found error, no module named Grok, because I'm not in my virtual environment right now. I forgot to do the source. The dot by itself means source the following file. Source in the terminal means that you take the following file and basically just copy it and paste it into the terminal. So I will source this vnv/bin/activate file. This is the way that we activate this virtual environment that contains all those libraries that we installed. Do that. You can see my prompt over here is changed so that I have this venv right over here now, reminding me that I'm in this virtual environment. And now if I press the up arrow back to this command and hit enter, then it's still not working yet because of the Grok API key environment variable issue. And my incantation to get access to that was export and then cat of .v.env like this. Again, exactly what your incantation is, how you've decided to arrange things is not super important as long as you're able to get things to run. But this is on a Mac or a Linux system, how you can get your environment variable here registered so that other programs can use it. And now up arrow, rerun this, and it is now summarizing this document for me. And my instructions here, I haven't changed the prompt or the instructions that I was giving this Python program here, this large language model in any way. I haven't changed that from what we were doing before. But the large language model automatically for us decided to translate its summary from Spanish into English. And so we have an English language summary now of this Spanish article that maybe would have been too difficult for us to read. So I just wanted to do this as highlight an example of a use case for LLMs in the summarization technology that even if you are like a great reader, you hate reading summaries, well, there's still many languages that you can't read, but the LLMs can, and the LLM can give us a nice summary of those documents for us. At this point, we haven't done anything new coding-wise, but there's a good spot to stop and see if people have questions about anything so far. Yeah, run.
How can we tell, assuming you can't speak Spanish, how can you tell with this summary that it's going to pass a test? Like, how do we know this has anything?
Yeah, so this is a great question. The question is, how do we how can we get more confidence that our code is doing what we want it to do? And we will see some ways to get some confidence that way today. But yeah, this is like a really big question in general when you're programming, but specifically with LLMs about how can I actually be confident that my code is doing what I think it should be doing? And yeah, the LLM could just be making all this up. It's given us a summary about people being detained at the border, I think. But if you don't speak Spanish, this could just be totally off the wall. You have no idea if it's actually correct or not. We will see so the techniques that we'll see today for ensuring correctness will not be able to talk about the large language model stuff in particular. But over maybe like 2 weeks from now, I'm hoping for us to talk about some ways of being more secure in the large language model itself being giving good results. So good question, the right sort of question to be thinking about, but we're not yet prepared to fully answer it. Yes?
More to process.
Sure.
Is it a problem if we just like manually add TXT files with the like docs? Under the docs folder, or do we have to like input them?
Question is, under the docs folder, is it a problem if you manually add these files somehow? And the answer is no. However you get the files into your docs folder doesn't matter. So if you wanted to use, if it was easier for you to use just say the GitHub webpage and press the download button one at a time on each of these documents, that would be a totally fine, acceptable thing to do. Once you have the things in this docs folder, it shouldn't matter how they got there, that it's the same file either way. So how things get there doesn't matter just as long as it's there. Yeah, good question. Okay, so let's think about a little bit of new stuff next with adding test cases here. And what I want to ensure is just that when I run my Python on this, this new file right here, that it is in fact going to successfully complete. It's going to run this file without any error messages. And we're not going to try to check that the output is correct. We can already see that the output here is going to be different every time I run this. And so it's very hard to check the correctness of the output. But one property that we can ensure is that the program doesn't crash, and that's what we will do. So up here in the top window, both of these windows, again, located in my docsum folder and my projects folder. It's just where I like to keep all of my projects. And ls-a, the -a for hidden files, again, on Unix machines, so Linux or Mac, any file that starts with a dot is a hidden file. The .env is the main hidden file we've seen so far, because we don't want our environment variables to be public. But this .github is another hidden file. This is where these GitHub Actions workflows are stored. And that's what we're going to modify our GitHub Actions so that it cares about this news.mx file as well. So I'll do vim.github/workflows/tests.yaml. Again, I'm not a very fast typer. I didn't type all that out. I pressed tab on my keyboard here to type all that out for me. Hit enter, and I'm going to go to the bottom of this file and Vim, Shift-G, take me down here. Line 29 is what I currently have that was running the test on the declaration.txt. I will do YYP to duplicate that, and FD, find the D over here, C $, delete that. And I want to change this to news-mx.txt right here. Run that, paste that here, escape :W. And now this is going to run 2 commands for me, making sure that both of these commands do in fact pass. Let's see, we're doing good on time, so I'm going to do what I'm going to do next. If I do git status right here, git status will tell me all the files that have been changed so far. I've changed these 2 files right here, plus these untracked files are all the new documents that I've added. And I'm going to add this test.yaml file, this new change up here. So git add.github like this. If I add a folder, it'll automatically add all of the subfolders for me. Git commit change the actions and git push origin master. And it's pushed that up to GitHub for me. What we should see, hopefully, is that our program is not going to work correctly at this point, that we've added this new text case with this new file, but I have not added this actual file to the repository. And so if I come over here and go to my actual repository for docsum up here, inside of the workflows, if I click on this and click on test.yaml, I can see that this change has taken effect up here, down here on this bottom line, line 30 right here. This line is now added, so it will run this line right here for me. But if I go back to docsum over here, and in docs over here, we can see that we only have the declaration.txt. We don't have that Mexican news article. And so if I click on actions next, this is the output of all of my runs, all of this continuous integration. We can see that there's a red here because it is failing. And why is it failing? If I click the show jobs right here, click the 3.9, I'll scroll down to the bottom once this loads. And we can see that it's failing on this command right here, trying to load the news-mx.txt, and it is not able to actually load that because it's not in the repository. So this, and coming down here, we'll see that, let's see, shift, reload that. Sometimes web browsers cache images for you, and so that they can save bandwidth, not have to re-download the image. In order to force it to re-download, you can hold down the Shift key while you refresh the web page. And doing that, it forced it to re-download this image, and we now see that it is failing instead of passing. So this test case, it is in fact checking to see that some things are working. It is doing something, even if it's not doing everything that we might possibly like out of a test case at this point. Coming back, how do we actually fix that? We need to actually add this document to this news-mx.txt file to this docs folder, ls docs. It's in this docs folder, but it's not added on git add docs/news that commits instead of change the actions. So this is the commit message right here, telling me what this commit is doing at a high level, so that there's a human readable thing, so you don't have to necessarily look at the code to understand what it's doing. And I'll just say add documents, and then push Control R in the terminal to search my history, push that back up. And once all those actions run again, this should turn green. There are a lot of things right there. Hopefully, at least at a high level, those all made sense. But any questions about that?
Yeah, I assume it's for GitHub reasons, but like, why do we have to put all our tests in like an entirely separate format that doesn't even look like it's running Python?
Question is, why are the tests in a separate format that doesn't look like it's running Python? And the answer is these tests are not, in fact, running Python. Under this run command right here, all of these lines are shell lines. So the terminal down here, this environment down here, and if I copy and paste one of these lines right here, this is exactly what is happening. So these are not Python commands, these are shell terminal commands. And one of the many reasons why Linux, and to a lesser extent Mac, but Unix in general, is the standard that all developers use on their personal machines, including at Microsoft. I have a lot of friends who work at Microsoft, and over half of the machines famously at Microsoft run Linux and not Windows. Even Microsoft acknowledges that Unix machines are the best things for developers because all of these sort of like development tools rely on a Unix environment. That this is a terminal command right here from the Unix environment, and it might not, it's a little bit confusing at first, like why it is the way it is, but this is the exact same environment down here as this. And so that's why I do my development. One of the reasons why I do my development in the terminal is because it's the same environment as GitHub Actions. Not sure if that answered your question.
Yeah, kind of. It's just like, like all the stuff kind of above there is just saying like very basic background things to running those programs that I would think would be like, I guess I'm just confused why you misstate those things explicitly every time. I guess it's so that you can customize it.
Yeah, so this is only one possible configuration of a system. The way to think about these GitHub Actions files is this is like a configuration of a computer, that these 30 lines right here fully describe how a computer should be configured in order to run these. And those could be configured differently, and in many situations are. Whenever this is one of the sort of things that I never would develop from scratch. Python files, I write from scratch all the time. GitHub Actions, it's always, I go to a project that I already know works, copy and paste that over, and because it's not worth trying to memorize all the weird incantations up here. Yeah, Max.
Are you able to see if your test cases pass before you commit it to GitHub?
Question is, can you see if the test cases pass before committing to GitHub? There is a thing called pre-commit hooks, which run on the local machine instead of the remote machine. Those can cover certain types of test cases, but not all test cases. So in general, the answer is no. And in general, people always push things to their remote repository like GitHub. And have that system automatically run the test cases. Good questions. Okay. So one thing that is staring at me as like a huge painful thing that we just did, and is maybe not like so painful to you all, but is hugely painful to me, is the fact that we're like manually having to copy and paste a whole bunch of stuff into this file right here with all of these different document names. And every time I want to add a new document to my test cases, I have to add it up here manually. I hate manual things, so we are going to automate that process. And I hate manual things because I hate typing, but also because it makes things break relatively often. Like we just saw the test cases before breaking because I added this up here, but I forgot to actually add it to the repository. And so what I'm going to do is for a file in docs/star. This is a for loop that runs, well, I'll type it up here and then explains exactly what's going to happen. Python 3. docsum.py file done. This will run the docsum.py for me on every file in this documents folder. If I paste this down here and hit enter, we have a lot of files that are broken at this point that we're going to have to fix, but we can see that it is in fact running on some of them. If I do this, let's do a move docs2, make dir docs, copy docs2 / declaration to docs, and copy docs2 / newsmx.txt docs. So these are the two files that I wanted to have as being test cases. They're now both in this docs folder. And now if I run this one command right here, it will run it on every file in that docs folder. And we can see there are no failing test cases there. And so this one line right here will run my Python program on all of the documents in the docs folder. And now to get my Python program to have more tests in it, all I have to do is add more documents to this docs folder. If the syntax of this incantation doesn't make sense at all, that's okay. It is a legitimately confusing incantation, but this is just a Python or just a terminal command that runs this Python command on every file in the docs folder. And again, you don't have to try to copy it down from scratch here on the screen. Again, all of these videos recorded on YouTube. So if there is something ever that you're not fully getting, you can watch it offline or after class on YouTube. And these documents also posted to GitHub, so you can just copy and paste from there. I'll go ahead and add this change to the GitHub repository. And so now that is available for you to just copy and paste if you would like. But the important thing is just that it's going to run all of our Python program on all the documents. And we saw before that there are some documents that it is not working on. And really the main part of class today, the important thing, most important thing, the thing related to large language models is how are we going to fix that so that it is going to actually pass here, run successfully on these tests. The file that I want to do that with is going to be this constitution-mx.txt. So I'm going to move that from my docs2 folder / constitution here over to my docs folder. So now we have 3 files right here, and this is the one that I want us to focus on. And Python 3 docsum.py docs/constitution. We'll see that this is currently failing for us, and it's failing for LLM specific reasons. And so we will next cover what those reasons are and how to fix that. Before I do that, though, any questions on where we're at, what we've done, or what we're doing? Ainsley. Excellent question. Okay. So here, this is an example of a confusing error message. What I've just done is I have, again, I'm running the same code, this docsum.py, what we've had for from our previous classes, what we've been running for a couple times so far today. And the only thing that I've changed is the document that I'm running it on, changing it to this constitution-mx.txt. And we can see that we're now getting this rate limit error. The reason that this is confusing is because if you Google this rate limit error, or if you try to ask ChatGPT how to fix this rate limit error, it is guaranteed to give you the wrong solution. The reason this is the wrong solution is because a rate limit error, the sort of standard solution to rate limit errors is to pause, don't do anything for a little bit, and then try again. But here, that's not going to work because the fundamental cause of our error is related to the Groq API, and Groq API has a limit of 30,000 tokens at any one time, but we have requested 93,000 tokens at once. This particular file contains 93,000 tokens inside of it, and Groq has this built-in limit of 30,000 tokens that you just can't exceed for any reason. And again, Groq is this free API, and so the reason why they have this limit is just to prevent people from totally burning through their VC cache on large projects. So we can only use up to 30,000 tokens at a time. And the recommended solution right here is to wait for 2 minutes and 7 seconds. But no matter how long we wait, the number of tokens right here that we are requesting is always going to exceed our limit of what we're allowed to do at once. And so there's no way that you can just wait to have this be fixed. In order to fix this, what we have to do is we actually have to break the document up into smaller parts and then pass those smaller parts to the model. And so that's what we will do here next. Again, our goal is, in order to handle these large documents, we're going to break the document up into smaller parts and deal with those smaller parts one at a time. Yes?
Just making sure when you break it up into parts, you're sending each part by itself. The model's not going to consider all of it.
Yeah, the question is exactly how are we going to transfer those parts to the model? Are we going to do it one at a time or all together somehow? And I had a small diagram that I was planning on drawing, but it looks like I forgot my little drawy thing, so I can't draw it out. But yeah, we're going to basically chunk the document up into smaller parts, summarizing each of those parts individually. Then we will create a new document out of those smaller summaries and summarize the summaries. So we'll sort of, that's why I call this technique recursive summarization, because we're going to break the document up into smaller parts, summarizing them into smaller documents, and then create a new document from that. The code for that is pretty straightforward, so hopefully the code, following along with the code, will make the actual technique here make a lot of sense. Let's see, in order to talk about this code, we're going to be modifying now the docsum.py file. So vim docsum.py. And again, I don't care how you are opening docsum or editing it. I use Vim in the terminal here, but anything works fine. I already have, I forgot to remove this. I already have some code that I was playing around with before class here. So I am going to remove that with git reset. Then the name of the file, what that does is it checks out the previous version of that file. So when I run git reset right here, it'll change that to be the version of the file that you all have access to, the version of the file that we had last time in class. And if I run vim docsum.py, git checkout docsum.py does that. Then it has removed that extra code that I added up there. Yeah, one of the weird things about Git, things that everybody complains about with Git, including Linus Torvalds, the author of Git, is that these commands here are very poorly named, and so it's easy to forget that I was thinking in my head, oh, reset resets the file to what it's used to be, but it's actually git checkout. Then the name of the file is how you reset the file to what it used to be. So now my version of the docsum.py should line up with yours, and we can talk about the different things that we'll need to do here to modify it. I'm going to switch my screens here for a second to be side by side so we can see a little bit more text here at once, so you can follow along a little bit more with what I'm doing. But again, our file here is fairly short. It's only 33 lines long here. And I'm going to add a new function up here at the top. We'll start here up at the top. A new function that's going to split our large document into chunks. So I'll call it split document into chunks like this. And for now, I'll just put the word pass right here. In Python, what pass means is that the contents of this function, it has no contents, it does nothing. But you can't in Python have a function that is empty because that's not syntactically correct. So pass here is just a standard way to make things syntactically correct, and you have a function that does nothing. On the right-hand side, let's see. I'm going to press Control-C here. I'm going to do another magic incantation here to change my prompt so that it's just a $sign down here, so that it's a little bit shorter, easier to read at once, so I can have my terminal side by side over here. The only thing that I've done is just change what the prompt is printing, so it's just a $sign. Whatever comes after the $sign is the command, and whatever does not have a $sign in front of it is the output of that command. And so I'm just going to rerun my program and verify that nothing bad has happened. Python 3. docsum.py, and then docs / we'll do the declaration since I know that works, and we still do in fact get the output over here. Another common mistake that I see students make all the time is that you make changes to your file and you don't actually run the file, verify that those changes have done nothing or done the thing that you expected. So as I'm working on things, whether it's in class here or on my own, I'm always running my documents, running my Python files like multiple times a minute. And if you're not in the habit of running your code multiple times a minute, you're not running your code enough. So you should be running your code all the time. And okay, so I have this outline or this name of a function over here. And what I want to do, the idea of what this function is going to do, what this function is going to do is it's going to split the input text into smaller chunks so that an LLM can process those chunks individually. In Python, it's customary after you define a function to have these 3 quotation marks right here. These are called the doc string of the function, and they provide human-readable inputs, human-readable documentation about what that function is supposed to do. And so this is what my function here is supposed to do. And here, as the parameter, I'll now have a text parameter that's going to be passed in as input. One of the things that is also nice about Python is that it's very easy to embed test cases into these doc strings. And so whenever I'm developing a new function, whether it's related to large language models or anything, the first thing that I always do is I write test cases that describe to me what is the purpose of this function. What is this function supposed to be doing? And here, this function splitting a document into chunks. If I have some input text like hello, let's see, we'll do this is a sentence and add some new lines. This is another paragraph. Then what I want the output of this this function to be is a list of all of the different paragraphs. So here's one paragraph right here, and here's another paragraph right here, and I'll describe right here. This is a sentence. This is the output, the ideal output of my function. This is another paragraph right here like this. And this is the ideal output of what this function is supposed to do when it has this as input. Any questions at this point about what this function is supposed to do or what the syntax here is? Maybe again, I'll just real quickly review the syntax. With what I'm doing, I have these 3 greater than signs. This is a Python command right here. Inside of this Python command, it is calling the same exact function right here, split document into chunks. It has one string as input. That string contains 2 paragraphs. I'm calling these paragraphs, even though they're on the same line, because they have this \n. \n is this new line character. So there's an empty line between these 2 sentences right here. And the output of this function is supposed to be a list. I know it's a list because of the square brackets, and each one of these entries in this list is one of the paragraphs of split documents into chunks. And I'm also just noticing that I have a little bit of a typo here, that at the end of this first sentence there's a period. Here there's no period, so I'll go ahead and add the period right here. And at this point, again, I'll stop for questions. Any questions about what this is doing?
Yeah, why are you splitting it up?
Question is, why am I splitting this text into chunks? And the answer is because when I was running my my code over here on the Mexican Constitution, we got this rate limit error saying that our limit was 30,000. We can only do 30,000 tokens at once when I've requested to have 93,000 tokens. So this document contained 93,000 tokens in it, but the API only allows 30,000 tokens at once. So this split document into chunks, the idea of what we're going to do is we're going to split this constitution into several chunks so that each one of those chunks individually fits under this limit, and then we will individually summarize those.
I was wondering more like, why are we making each paragraph into its own chunk?
Question is, why are we making each paragraph into its own chunk? And the answer is, this is just an arbitrary choice that I just made right here. Lots of different ways that you could chunk up a document, and this is just the one that I happen to pick off the top of my head. Yeah, if we were developing like a serious large language model application, we would probably think about like multiple different ways of splitting documents into chunks, trying all of them, seeing which one works the best, and then picking that for our final application. But this is a easy enough one to understand, so that's why I just picked that. Good question. Okay, any other questions at this point? Okay, so at this point, this is probably the sort of function that like could exist in an intro Python course and would make a great function to work on for an intro programming student with different string manipulation. And I could add more test cases about different things that it could do. But I'm not going to write out this function manually. I'm going to just ask the LLM to write this function for me. And anytime that I am asking an LLM to write a function for me, I always follow this same pattern right here of define the function with a very like long descriptive name about what the function is supposed to be doing, add this human readable description about what the function is supposed to be doing and why I'm doing it, chunks so that an LLM can process those chunks individually. It's not a very like detailed description here, but it's hopefully enough to get the point across. And then I'll have a handful of test cases here about what I want the code to actually do. If I were doing this in earnest, in anger, then I would probably add more test cases and think a little bit harder about this this function call up here. But this will be good enough for us at this point, just to go throw this into the LLM and see what comes out. In order to get this into the LLM, I'm going to do set no number over here again, turn off those numbers so I can copy and paste this. I'm going to not include the pass command right here, come back over to my Firefox window, find Grok I have open, and here this is just the console where I can type with the large language model, and I will say write the code for the following function, keep the doc string exactly as enter, period, copy and paste that. And here is the code for my function. It's decided to do a very simple implementation right here that we probably could have figured out on our own. Let's see. Let's make this a little bit more complicated. Let's tell it to add more test cases for weird edge cases. Ensure that the test cases are input into the doc string and the code passes the new test cases. And so I might do some back and forth here. Okay, so we've got a bunch of new test cases here, and I still have this simple Python code. In general, having simple Python code is always a good thing, though, and I can look at this to see, like, is this really what I'm expecting to have the output be? And I can look at each one of these test cases, and they all look reasonable. So, like, here we have some extra new lines at the end. Those aren't messing up my output. Here we got a pretty bad one right here, though. This is saying this is a sentence with some new lines at the end with some empty test cases. So this is just not correct. But this one up here looks good. I'm going to go ahead and recopy and paste this whole thing into into my copy, down over here, paste that, delete the old thing right here. And now we have a bunch of test cases that may work, may not work. We're going to try to figure out whether they are going to pass or not pass. But I've just asked the large language model, again, to write the code for me. It turned out to be simple code in this case, and add a bunch more test cases for me. In order to run this code in Python, so Python 3-m doctest. Doctest is the name of the module that runs these doc tests. They're called doc tests. The name of the module also called doc tests. And it's going to run them and make sure that they are passing, giving me the correct output. Python 3-m doctest, and then the name of my program, docsum.py, hit enter. And here we get this, the first thing that comes up here is we get this value error, line 19, :set number, line 19, GG. Right here has inconsistent leading white space. That is caused by some white space issues here. I don't see a white space issue. Well, I don't know. That test doesn't look super important. Let's just delete it and see what happens. Still line 19 of the doc string, leading white space. Where am I getting this issue? Well, let's just delete a bunch of stuff and see what happens. So one of the reasons why I like to do live coding of things is sometimes weird stuff like this happens, and you can see the way that I walk through weird error messages to get those fixed. So here I have just started deleting doc strings, doc tests that seemed like they were causing error messages. So this is a sentence, EOL while scanning. Sometimes when copying stuff over from, I see what the problem is now. Sometimes when copying stuff over from the internet, some weird things happen. And in this case, there's a very subtle thing that happens all the time to me when I'm doing with doc strings about the way these \ins are being handled. And we have to recall that these doc strings are proper Python strings. And so this is a string right here. And so when this string, when Python first interprets it, it sees these \ins as part of this string up here. It actually interprets them as \ins. And so there is a new line being inserted right here, not in front of this quotation mark right there. If that explanation didn't make sense, the fix to this is just adding a little R right here, stands for raw string. Doc strings typically should be interpreted as raw strings, and that should fix this. And in fact, it did fix that right there. So the takeaway is just that your doc string should always have an R up here in Python for raw strings, so that it doesn't interpret these \ins or other escape characters, and that should be part of the actual test case. I'm going to go really fast right now, though, because we have 10 minutes left, and I want to make sure we get put the glue together on all this stuff. So we have the test cases running here. You can see that it's actually running my LLM code down here, though. I don't want it to run the LLM code. I want it to just run the test cases and nothing else. And in Python, in order to make the code down here not run when the module is being loaded as an import or a doc test or some way where it's not being called directly, the way you do that is with these, it's called a dunder variable or a magic variable in Python. Line 13 here, if _name equals _main. The name of this variable right here is a special variable. I know it's special because it has these double underscores in front and after it. And these Python is going to interpret this. When I'm loading a doc test, see that it's being loaded as a doc test and not actually being run. And whatever's inside this if statement here will not get evaluated. So I'll put everything else inside this if statement by copying it in Vim and just tabbing it all over. Now on the right-hand side, up and enter, and we get that there is no output. That means that the docs tests all pass, and it is not, in fact, running any of this stuff down here. Up here, I now only have one doc test over here. I need to recopy over the doc tests from over here. So we are at the first one, skip that, add these other ones, copy those, add them in right here, paste those. Now we have a lot of tests here. It's good to have code with a lot of tests. It gives reviewers of your code high confidence that the code is going to do what it wants, or to help them just even understand what the code is supposed to be doing. Now you can see that 4 of those are in fact not passing, that the large language model that we used wrote 4 test cases that are not good test cases, that they're not working. The output over here on the right-hand side shows what those test cases are. And in particular, so for this last one over here, we can see that it's adding these extra quotation marks, these strings that are should not be there, but they are. The reason it's adding those is because we have these \ins over here. \ins right here, and so the split command is interpreting this, adding an extra string at the end, adding an extra string at the end over here, and we don't want that to be in there. So we could fix this by going back to the LLM and asking it to refine its code to update the test cases, but we're running a little bit short of time, so we're not going to do that. But for your final homework submission, you'll want to have a large set of test cases, something like this, and it should actually pass those test cases. Running the doc test like this should actually pass those test cases. Now up here, I'm going to also open my GitHub workflows test.yaml, Shift-G, take me to the bottom, and add another test down here of actually running the doc tests like this. Python 3-m doc test docsum.py. And so we'll both make sure that we're passing the doc tests and that all the files in the folder are getting properly summarized without any error right here. Save that, come back here, save that. The last thing that we have to do is we have to take the output of this command right here, output of split document into chunks, and we need to use that with our chat completions down here. So I'm going to write a comment right here about what we still need to do. I'll use the multi-line string notation in Python to write this comment, but we need to call the split document into chunks on text. Then for each result, for each paragraph in the output list, call the LLM code below to summarize it, and then put the summary into a new list, concatenate that new list into one smaller document, and then recall the LLM code below on the new smaller document. So there's a little bit of coding here that you'll have to think about what to do for the homework assignment, but this should all be hopefully relatively straightforward about what you need to do. With this pseudocode right here, all of this stuff in this pseudocode here is not stuff that can be easily tested, again, because it's all relying on the LLM here. It's going to have different non-deterministic output depending on what the LLM decides to do at each time. But this code up here, the split document into chunks, this is something that does not rely on the LLM in any way whatsoever. And so this is something that we can have these proper test cases for. One of the, I hope, takeaways from this class, anytime we're doing this sort of engineering stuff, is getting you to think about, like, where in my code can I divide the code into these like logical segments of code that is easy to test by itself. And there's going to be lots of these sort of helper functions that you'll need for working with LLMs, but they don't involve the LLMs at all. And so you can write nice tests for these, for at least this amount of code, and get some assurances that this code is doing what you want it to do. Did a lot of things just then without pausing. Any questions about what this is doing or what you have to do for the homework? Rowan first.
So the format of getting the test cases is just like you have the 3 carrots and then you write some like test function and then it's just a new line with the answer.
Yeah, so the question is the format for these doc tests over here, where exactly is it coming from, how to do it? If you just in the terminal, if you type Python 3 by itself, you get these 3 carrots where you type in some Python code like 1 + 2 and you get 3 as the output. And so the intuition behind these doc tests, the way that people think about them is that this is like a session in the terminal of somebody who's just started Python 3. And now if you were to just type in this thing right here in the terminal exactly, what is Python going to spit out in the terminal as the exact answer? And the next line below that, that is the exact answer of what this thing up here is supposed to print out. So there's a very common way of documenting projects, I call it lightweight documentation. It's easy to insert it directly into your code. Helps reviewers, humans who are reviewing your code, understand what the split document into chunks is actually supposed to do, because the summary up here might not cover all of those edge cases. And it also helps like large language models or other automated tools figure out the code for you automatically. Yeah, good question. I think Ethan first, did you have a question?
Yeah, that kind of answers my question. Basically, it's the terminal and then there's text. It's like trying to text cases with causing error.
Yep.
So do we get to see like what the output when we run those cases?
The question is, do we get to see like what exactly it would have output if you hit enter like this? So on here, the test case on line 18 looked like this. So this is the failed example. This is the thing that it typed into the terminal. This is what it was supposed to give right here, but this is what it ended up giving instead. And so you can compare the expected. This is the expected is the thing that's in the terminal over or in the file itself over here. Compare that to the got, what it actually got, and you can see, oh, maybe I had a typo in what I had over here, and I can fix that. Or maybe it was just like actually wrong, and I need to fix my code so that it does the right thing. That's how you read this: expected versus got. The expected is the thing that was in the file. The got is the thing that it actually got. And those should be the same. Whenever they're the same, there's no output, and that's what you want from doc test. Questions on?
When you're doing like the carrots into the Python, like running them, do you do that within a doc string?
Question is, yes, does this happen inside of a doc string? And the answer is yes. All of this up here is inside of a doc string. So all of this is the quotation mark at the very beginning of a Python function right here. And so it's called a doc string because it's a string that documents your function. And so all of this is inside the doc string. Good question. That's pretty much time for class today. If people still have other questions, happy to stick around for as long as people have questions, get those answered. Also, I have office hours tomorrow from 9 to 11 a.m. So if any of this was weird or hard to you, or you want to review how things like these doc tests are working, how can you test your code, or you think you have something working, want to check if it's correct or not, feel free to come by and we will get those questions answered during office hours. Again, 9 to 11 a.m. tomorrow office hours, or I'll stick around after class and get your questions answered now. Yes.